Hello students, this is Miss Dalton, and today we're going to be talking about perpendicular lines. Perpendicular lines are lines that, that form 90-degree angles. So they're going to look like this, and a lot of times the symbol that we use to show that they are perpendicular is we'll put a box right there in the corner, and that's showing that this angle right here in the middle is a 90-degree angle. But a lot of times we're not given that information. We aren't told that they're perpendicular. So we need to have a way that we can verify that the lines are perpendicular, and that's going to be by looking at their slopes. So let's investigate what's going to happen to the slopes of perpendicular lines. In this first example, line A and B are perpendicular, and lines C and D are perpendicular. So we're going to complete this table. So first we're going to look at line A. Line A, if we want to find out what the slope is for line A, we're going to pick any 2 points on that line. I'm just going to pick these ones at the end. And we're going to count, if you remember, your slope is rise over run. So we're going to pick 2 points and we're going to count the rise and the run. So let's pick these 2 points here at the end. So if I'm going to rise from this point to this point, rise, I'm only going to rise 1 unit or 1 box, and run, I'm running 2 boxes. So if I write that as rise over run, the rise is 1 and that's over 2. Okay, well let's look at line B. Line B is down here, and we're going to pick 2 points on line B and we're going to count the rise and the run. So if I pick these points down here at the bottom, I'm going to rise 2, and since I have to go back to the left, that's going to be a -1. So if I write it as rise, you want to put the rise on top, which would be 2, and on the bottom was the run, which is a -1. Now this is going to simplify to just be -2. All right, let's look at line C now. Line C, if I'm going to find the slope, let's pick 2 points. I'll pick these at the bottom. So if I'm going to count the rise, I'm going to rise from that point, and I'm going to go up 1, 2, 3 boxes. So the rise is 3. And then I'm going to have to run to the right 2 boxes, so that would be a +2. So if you do the rise on top, that's going to be 3, and the run on bottom, which is 2. Okay, now let's look at point D. Or I'm sorry, line D. Line D, if I count the rise, I'm going to go up 2. If I'm counting from this bottom point here, I had to go up 2, and then go back to the left. You had to go left 3, so we're going to put -3. So the rise is 2. The run was -3, which would just simplify to be a -2/3. Okay, well let's look at the 2 lines that are perpendicular, each pair of lines that are perpendicular. So they said that A and B are perpendicular. The symbol that we use for perpendicular is an upside down T. They also said that C and D are perpendicular. So let's compare those. If you look at those 2 slopes, notice how this slope 1/2, when I flip it, it becomes this slope, and then I just had to change the sign. Well, let's see what happens with the bottom 2 slopes. If I take 3/2 and I flip it, then I'm going to get 2/3 and make it negative. So what we can conclude about the slopes of lines that are perpendicular is that the slopes are opposite reciprocals of each other. So if you take 2 lines and you find the slopes of those 2 lines, if they are opposites, so one's positive, one's negative, and if they are reciprocals, meaning that you flip them and they could be the same thing, then they are perpendicular lines. So let's look at this next example. They want us to complete the chart. They give us a slope and they want us to write the perpendicular slope. Well, the given slope 2/3, the perpendicular slope, of course, is going to be negative because this one's positive. So if one of them is positive, then the other one has to be negative, and then you just have to flip it. So it would be 3/2. Simple enough. Now, in the next slope, the given slope is -4. Now, let's remember that that's -4/1. So it's going to be the opposite, which means it's going to be a positive, and then we flip it, so it would be 1/4. Okay, easy enough. -1/4. Well, let's change the sign, so let's make it positive, and then let's flip it. So 4 is going to be on top, and 1 is going to be on the bottom. 2, again, 2, remember that that's 2/1, so the perpendicular slope would be a -1/2. Okay, now let's look at these next two. 0. Remember, 0 can be over any number. Okay, but when we flip 0 over any number and we make it negative, so now we're going to have some number on top and we're going to have 0 on the bottom. Well, you can't have 0 on the bottom. That can't happen. So that's when it's called undefined. Okay? Well, then vice versa, if you have an undefined slope, then the perpendicular slope would just be 0. Okay? So just remember that 0, when the perpendicular slope of 0 is undefined, and vice versa, undefined, the perpendicular slope is 0. Okay, let's look at these next examples. It says use the slopes to determine if the given lines are perpendicular. Well, in this first example, it looks like we have these equations written in slope-intercept form, which, if you remember, is y equals mx plus b. So what letter stands for slope? Well, the slope is your m. So if I look at my m in this first equation, it's going to be -1/2. Well, in this second equation, y equals mx, so m would be 2. Is -1/2 and 2, are they opposite reciprocals? Well, one of them's negative, one of them's positive, so that checks. Now, are they reciprocals of each other? 1/2, if I flip that, 1/2, it's going to become 2/1. So yes, they are perpendicular. I'm just going to put the perpendicular symbol. Okay, now let's look at this next one. Y equals 3x plus 7. So remember, your slope is 3. And y equals -3x. My slope is -3. Well, if I have 3, 3 is 3/1. So if I make it the opposite, it is going to be negative. But when I flip this, it's going to be 1/3, which is not that. So no, not perpendicular. Okay, in this last example, it says write the equation in slope-intercept form of the line that passes through the given point and is perpendicular to the graph of the given equation. So it's going to go through this point right here. So this is going to be an x and a y value for my equation, and it needs to be perpendicular to this line. Well, the slope of this line is 2/9. So the perpendicular slope would be the opposite, so it would be negative. Reciprocal, so I'm going to flip that, and so it would be 9/2. Well, as long as I have a point and I have a slope, then I can write the equation for my line. Remember, let's start with y equals mx plus b. And let's put in what we know. We know that y is negative 13. So let's put that in place of y. We know that m of our new line is negative 9 over 2. So put negative 9 over 2 in place of m. And then our x is 6. And the plus b is something that we don't know yet. So we're just going to put plus b. Well, let's go ahead and solve for b, because b is our only variable here, so now we can solve it. So we have negative 13 equals negative 9 over 2 times 6 is negative 27. You can check that on your calculator if you don't trust me. That's plus b. Okay, well, to get b by itself, we need to move this negative 27 over to the other side. So to do that, we're going to add 27 to both sides. That's going to give us our 0 pair right here. And so we're going to have on the right side b, and on the left side, negative 13 plus 27 is 14. So it looks like b is 14, and our slope is negative 9/2. So now we can write the equation. Y equals m, which is negative 9 over 2, x plus b, which is 14. And there's our equation for our perpendicular line that goes through this point. All right, that's it for tonight. Please fill out your WISC and come to class with any questions that you have from the video.